Hello everyone, welcome to Vijay Codes It. So in our previous video, we started seeing how the memory management is done in Spark. In previous video, we have seen how the memory is managed within the driver. If you haven't watched our previous video, I would recommend watching that video because we would be continuing on that video in this video. And also, if you haven't subscribed to the channel, please subscribe it as it gives us the motivation to create the quality content. Let's start. So in today's video, we are going to see memory management in executors. So let me quickly draw out the architecture of Spark. Let's say we have a driver of 10 GB and how the memory is managed within the driver. We have seen this in previous video. And let's say we have three executors, E1, E2, E3 of 20 GB each. So this is the architecture of Spark. Now to learn how memory is managed within the executors, let's zoom out on one of the executors. Okay, so what happens is, suppose we request 10 GB of executor from Spark. So what will happen is Spark will give us basically 10 GB plus 10% of requested size. So what will happen is we will be getting 11 GB of executor. Why are we getting this 10% extra over here? It is because of overhead memory. So as we have overhead memory in our driver, we also have it in our executor. So over here, 10 GB would be for 10 GB would be for JVM processes and 1 GB would be for non-JVM processes. Okay, so what is non-JVM processes? Non-JVM processes would be like PySpark application. In our Spark architecture video, we have seen that how the PySpark application is converted into the JVM application. So I would highly recommend watching our Spark architecture video to get more understanding on it. And also this 1 GB would be contributing to the container creation and management. So that's how we get 11 GB. So it would something visually look like we have 1 GB reserved for non-JVM processes and 10 GB for JVM processes. Now let's zoom in more on JVM processes. So I've drawn out the orange one, which is basically 10 GB in size. So in JVM processes, we have three type of memories. First one is user memory, reserved memory, and Spark memory. So by default, this reserved memory is of 300 MB and Spark memory is 60% of remaining. So in our case, the executor size was of 10 GB. So 10 GB minus 300 MB, that is equal to 9.7 GB. So 60% of remaining, that is 60% of 9.7 GB. And user memory would be 40% of 9.7 GB. This is how the memory is divided within the Spark executor. Now, let's understand the uses of each of the memory. Let's start with reserved memory. Reserved memory is used for storing the Spark internal objects. And by Spark engine. So over here, the reserve memory is used for like storing the internal objects of Spark, which is native to Spark and not created by the user, which are used by the Spark engine. Now let's see what is the usage of user memory. So user memory is used to store user defined data structure, the metadata of the data, and any UTF which is created by the user. It is also used if we are doing the low level code. That is, if we are using RDDs. To understand what exactly RDDs are, you can watch our RDD in Spark video, and in that video we have explained in detail. So if we are using RDDs, it uses the user memory within the executor, and if we are using like a high level APIs, it uses Spark memory. So if we are using the data frame, now let's see Spark memory. So if using data frame, Spark memory is utilized. Also, Spark memory is divided into two parts. First one, executor memory, and second one is storage memory. Executor memory is used to store the object required during execution. So store the object which are required during the execution. It can be like storing the hash table in our shuffle sort join versus shuffle hash join video. We mentioned that shuffle hash join takes place in memory. So this is where the hash table is stored within the memory. And we like talked in that video that if our hash table is too big, we may get executor out of memory. So this is like one of the reason that we get executor out of memory. I would recommend highly to watch our shuffle hash join, shuffle sort join video to like get an idea what exactly hash table is and how it is created. It is used for spilling in disk, and it is like very short-lived. So once like our operation is successful, it get like cleared out. So executor memory is cleared out after the execution. But whereas storage memory is concerned, it is used for caching. So like we can store the intermediate result in storage memory. And let's say our storage memory and executor memory both are full, but like storage memory is using the space of executor memory, then the eviction is done in LRU fashion. LRU is least recently used. I know that it may sound kind of confusing, so let's visualize it with the help of a diagram. So now we will be looking inside of Spark memory. So this is the Spark memory, and by default, it is 50%, 50% for the storage memory, and 50% for executor memory. But this was the case before Spark 1.6.0. After 1.6.0, we have like a dynamic thing. So it keeps on changing as per the need. There are like two types of memory manager in Spark. One is static memory manager, which was used in Spark version 1.6.4 and before. But now we use unified memory manager. So it is kind of an interview question. What are two types of memory manager in Spark? So they are static memory manager and unified memory manager. Static memory manager was used before Spark 1.6.0, and from then onwards, we are using unified memory manager. Now let's understand how unified memory manager works. Static basically is like we have like a fixed boundary within the Spark memory, and unified is basically like it will be keep on changing as per the needs. So let's say we have like done a cache. We have executed df.cache. Over here, we have seen that the cache is stored within the storage memory. So let's say this is the storage memory. So what will happen is it will start creating the partitions within the storage memory to store the cache. And once the storage memory is full, it would be utilizing the space of executor memory. This is our storage memory, and this is our executor memory. Now, what happens is, let's say we are doing a join, and for that we need it would be happening in the executor memory. Let's say we have like taken 4 core, so we can run like 4 tasks in parallel. And if there are like there is no need of 4 partitions, we can do it in 2 partitions as well. So let's say we have four cores, so we have 4 partitions running parallel. What we can do is like if it requires more memory, it would keep on taking more space. And now let's say that the memory executor memory is full. What will happen now is the cache stored in storage memory would be getting evicted in least recently used manner. So let's say this cache, this partition is not used that frequently. So what will happen is this will be evicted, and now this evicted memory can be utilized by the executors. So like that. And then again, the executor memory is full. Now again, the storage memory has to be evicted. So it will be evicted, and that's how we will again utilize the evicted memory, and it will keep on happening till the point where both storage memory and executor memory both are utilized. So if storage memory and executor memory both are utilized, in this case, we will definitely get executor out of memory. Now the question would be that there is a concept of disk spillage, that the executor would be like spilling the data on the disk. So let's clear that out. Let's say we are joining on 2 data frames, and 2 data frames are too big, that we have like multiple values, 100, 100, 100, 100, 20, 20, 20, 100, 100, 100, 20, 20. So when we do join, what happens is we need to bring the same key on the same executor. Uh, if you haven't watched our join video, how join happens in Spark, please watch our video on join to get more deeper understanding. We won't go in that depth in this video. So we have seen in our video that to perform the join, we need to bring the same key on the same executor. So let's assume that the size of this is like around 4 GB. I've seen over here is that Spark memory is 60% of 9.7 GB, and 60% of 9.7 GB is approximately about 6 GB. But the thing is, Then this 6 GB is divided into storage memory and executor memory, which is approximately 50%. And this 6 GB is again divided into two parts. Then the executor memory is of 3 GB, but the data of single key is of 4 GB. So we are trying to bring 4 GB of data into our executor, which is of 3 GB. And in that case, we won't be able to perform the join because the executor memory is very less. And to perform the join, we need to have the data in like one executor itself. And the executor memory is small and the data won't be able to fit into it. Due to that reason, we will be getting executor out of memory error. And we won't be able to spill the data because we need the data within a single executor. So in this scenario, we won't be able to write the data to the disk. So in today's video, we saw how and when we get executor out of memory error. Today's video is kind of confusing, so I would recommend going through this video once again. And if you have any questions, you can like drop the comment and I can try my best to answer those questions. So that's it for today. Thank you for watching. Keep learning.